Hello and welcome. Welcome to my workshop on tracking Core Web Vitals, what that means, what Core Web Vitals are, and what that means in the context of real user monitoring. We will dive into all of that today. So excited to be here with you at API Days. What a wonderful day. I'm going to give you the context for what this is and what we're doing. So this is a hands-on lab. This is a lab that you will be able to repeat step by step. So I'm going to be following along that pattern as I do this. You will be able to walk through each step and redo what I'm doing exactly with Datadog and in this platform that we use at Datadog called Instruct to deliver labs. So right now, Instruct is booting up an environment for me to demonstrate what I'm doing. So I'm excited for that to get going. But in the meantime, let's explain a couple things. Like maybe you don't know exactly what real user monitoring is, or maybe you don't know what Core Web Vitals are, and that's fine. You'll understand that by the end of this workshop. So the difference between, well, let's see. Let me start with real user monitoring. So real user monitoring is an observability practice that allows you to understand what's actually going on with your real users in production. And you're probably used to auditing the performance of your app, your web app, with the Chrome the Chrome Dev Tools, or Lighthouse auditing using a Lighthouse audit and getting scores. And those are all great. Those are all wonderful. But a tool like RUM allows you to actually funnel and aggregate all of the data that is being pushed around by your actual users to be able to see it in one clear view. And the cool thing about that is you're also able to, within these views, able to track things like Core Web Vitals. And Core Web Vitals are the heartbeat of your user experience and how to measure that and how to track that. So let's get started with this workshop. So right now, as I said, you have that you will be able to repeat this workshop yourself, and we will provide the link to that in post. But for now, you can follow along. So in this environment, you'll see that we have three items here, three tabs. One is a terminal, and one is an IDE, which is an instance of VS Code. And the other is the application that we're going to be using to demonstrate how to track Core Web Vitals within your application and mitigate issues that happen within that context. So let me get started. So I'm going to start out by seeing if I have some credentials for Datadog, which I do. So when you sign up within our labs, our learning labs, you'll get a set of credentials that will allow you to access app.datadog.com, which is this. So this is the Datadog app. Right now, I haven't really selected anything as far as all of the different tools within Datadog, but I have logged in with a temporary user, which you will get when you sign up as well for this. So I have credentials. That's great. I have an API key. That is great. So what are Core Web Vitals? What are we talking about? Core Web Vitals, they are a set of signals. They're a set of distinct, measurable quality signals that help you understand, correlate moments in time to user events that users experience within your application. So if you are loading a page, or you want to do something with the page, or you want to understand the time that is introduced by shifting elements around on the page, all of these things have to do with Core Web Vital, with the web vitals that are measurable, that affect your user experience. And it's really important to understand these, and it's become it's become a de facto way of measuring the user experience, which in the end affects your bottom line. Because if users don't like your application, or they find it frustrating to load or to use, they will bounce. So these are really important to measure. There are more than the set of 3 core web vitals within the entire set of web vitals, but the ones that are core are these, and those are the largest contentful paint, the first input delay, and your cumulative layout shift. And I'll go through each of these real briefly. So largest contentful paint. This is when the largest DOM element has been rendered and is getting painted in the view of your app. So that measures that moment in time. How long did it take from initial request to getting to the LCP, which is when you start to actually see the app on your screen as a user. The first input delay, that's number 2. First input delay is how much time it took from when an element on your app became on the index of your app became interactive, and a user tried to use it. So when they tried to use it, what was the latency of time between when they first tried to use it and when the result occurred or was rendered on screen or whatnot. So when a user tried to use it and when the result happened is the first input delay. And then the cumulative layout shift is you've probably opened up a site and a bunch of stuff loaded on the page, and you were like, yeah, I'm going to use this site. I'm going to click on this thing. And then the site goes boop, and a big ad or a banner or something pops up. And instead of clicking on what you wanted to click on, you click on that banner. Not very fun. Core Web Vitals measure that. That's called cumulative layout shift. So if there are elements that load after all of the DOM content the initial DOM content has loaded, it's important to understand that that can dramatically affect the user experience. So we also measure the cumulative layout shift. So within this context, why is tracking these important? It affects, as I said before, your bottom line. So there's a lot of data and case studies from very large businesses that, like Pinterest and Netflix and all sorts of people that showed the dramatic percentage increase of new user adoption and also of bouncing of user bounce rates and things like that. There's actually a really great case study about the business impact of Core Web Vitals that Google made recently. So this affects your bottom line. The longer it takes to load a page for a user after 2.5 seconds, the more likely they are to bounce. And that should be, reason number 1 that you would like to, ensure that your page is performing well within these contexts. Number 2, the Google searching algorithm has also in 2020 has also adopted these. So the SEO ranking of your site is going to be directly affected by how well your site performs within the context of Core Web Vitals. So that makes it also important for discoverability. So let's kind of jump in here. So we've talked about Core Web Vitals and what they are. Now let's understand what RUM is and how to use it and how to collect these Core Web Vital metrics from an application within this context. So I'm going to boot up my IDE here and just show you what we're doing. So here's a Docker Compose file, and I've got a few different services here that are running in this environment to run this e-commerce application called StoreDog, and we'll take a look at that in a moment. But in Docker Compose, my Docker Compose file here, you can see that we have a few services that are also running in their own containers. So we've got the environment, and we have the front end, and we have an advertisements service, and we also have a discounts service. I might have skipped that front end, let's see, advertisements, and then there should be a discounts service somewhere, but it's probably up there. Anyways, and we also have a database and a Puppeteer, container running Puppeteer. Now, so for the interest of being able to demonstrate something interesting today, I'm running Puppeteer, which is helping me simulate mobile traffic. So normally in the context of real user monitoring, you would have a bunch of people using your app, right? Which is what you want. And so I'm essentially doing session replay for a lot of mobile traffic on this particular site so that you can see what it looks like when you're using it in production. That's what Puppeteer does. But the important things that we are going to use today are the advertisements agent and the discounts agent. So that's going to be important for today. And then, yeah, and within that, now we need to understand how to configure Datadog's RUM to be able to use it. So let me do that. Okay, so if you go to app.datadoghq.com, this is, and you have your credentials, this is what you're going to be presented with, this sort of thing. And you'll want to create a new RUM application to be able to work in tandem with your app. So in the UX monitoring category, that's what you want to use. You can go to navigate to RUM applications, and then I have already created this app, but you would go through the process of creating a new application. You can actually see that if you edit this one, which you'll instantiate a JS application, name it whatever the name of your app is. And then the cool thing is this is pretty much all you need to get started, to get your hands dirty with aggregating your user data to Datadog. And yes, you can, it should be set up front. You can filter out user data and sensitive information. That's no problem. You just have to add a little bit of configuration to do that, but it's very doable. So if you don't want to aggregate sensitive user information up to Datadog, no problem. So within this, usually when you're building an app, it's a React on the front end. It'd be a React app, or whatever framework you're using, and you're probably using Node and tools like that. So within this context, you can grab the Datadog npm module and then initialize in your index.js file. And this is how you would do that. You provide the application ID. This you just literally copy and paste this code. It provides the app ID that Datadog uses and the client token that Datadog uses to connect. And yeah, and then you just start aggregating data using this in tandem with the Datadog agent. So that is pretty exciting. And I'll skip through this. And so, yeah, okay. So now, we can take a look at what this looks like in the context of this app. I'm going to head over to store front end, and then app, and views, and spree, and layouts. And this should be it, right? Yeah, oof, what's going on here? Let's do this. Maybe get rid of that. Yeah, okay. Okay, so normally, or I guess in more recent times, you probably aren't using a Ruby application. So please, ignore it, which is fine. This is just more of a legacy Ruby example. But so just ignore the Ruby syntax here, the Rails stuff, and just you can see that what we've really got here is JavaScript and HTML. So that is super useful. So in this context, we're just attaching the Datadog RUM object to the window, initializing it, and then in the environment variables, as you can see, they've been instantiated through the local environment. And this will pick that up and run with it and start pushing data up to Datadog, which is great. So for our intents and purposes, we have a little tool called set RUM vars, which essentially does that locally. And we can check that we have set those variables by doing this. Great. So we've got our RUM vars set locally in the environment. And now we're going to run our app and see what it looks like. So we've got all these services booting up. And there we go. They are all starting to run in the background here. And it might take a moment to connect to boot up here. Yeah, it's going to take a moment for this to work, but we will wait for that. Yeah. Oh, yeah. In the meantime, it's really important to note that you need to to get logs into Datadog. You simply have to navigate to the logs view here. And then once you navigate there, it will instantiate the logs for your app that you have just set up locally. So pretty simple. All you got to do is go to logs, and then, logs won't be coming. I guess what I'm saying is logs won't be coming through until you go to the logs view, and then it will kick off the logging process. So you can see that we have different logs coming through from the agent, from the storefront, and the discount service. So all this looks good. So we're excited to have that coming through, which will be very important, especially when we get into debugging our app here. So let's see if StoreDog is running. Looks like it is. Great. Okay, so here we have an e-commerce application. Now, as you can see, some things took a little while to load on the page. You can just see visually. So the experience is not just at the onset, doesn't seem as good as it could be. But this is what we've got to work with right now. So we will be working with this app. And oh, sorry. And this yeah, so StoreDog, it's a e-commerce application. You can buy cool hats, you can buy totes, you can buy lots of things. You can put them in your shopping cart. It's great. We want to create a great experience for everyone who wants to buy these things. But we're having some performance issues. So we need on the front end. So we need to dive in and figure out what that is. And in order to do that, we're going to have to start to look into what our core web vitals are, because those are the set of signals that help us understand what the actual user experience is right now. So normally when people look into tracking core web vitals for an application, the first thing that they think of is popping open the dev tools, right? That's usually the front end person's first stop. Is you pop open the dev tools and you go to Lighthouse and you say, okay, well, I want to understand what my mobile traffic looks like, and you generate a report, and then it starts running the report. And this is good. This is obviously a great tool to be able to get a snapshot in time of based on current statistics and like all these variables that give you a general score that you can use to be able to understand what your actual experience is right now. And that's great. But what most people, and the performance is terrible. So what most people don't realize or don't tend to jump into is there's a gap between this and doing this synthetically with general calculate. This is a synthetic calculation of a best estimate guess of what your performance is, and it's accurate, but this doesn't show you what's actually going on with your real users per user, per session, per route. All these questions that you might have of like, this is a great overview. We can see what our performance was of the app, which definitely needs improving. And we also get the metrics that led us there, which are this is a core web vital, a first contentful paint, 8.7 seconds. That's really bad. Or sorry, the largest contentful paint, yeah, the LCP is the core web vital. So the time it took us to get to the LCP was 11.7 seconds. That's really bad. Time to interactive was bad. Not doing too bad on the cumulative layout shift, I guess, because there's not a lot of things moving. And the total, you can get all these stats and get advice on what to mitigate, which is great. But this is one stop. This is like a quick overview, and doesn't give you the view of how this is going with your actual users, which both of these tools are incredibly valuable. But most people tend to use this and then not make that jump. So you can, just for demonstration, many developers use Lighthouse, and then they also might use the performance tab to understand what their core web vitals are. So what this does is it takes a snapshot of your app's performance. So you would click, actually I need my to be able, oh, there, that's reload. Okay, so I need to do this, and I'm gonna have to do this. Okay, so I just did a hard reload of the app, and after I stop, this process was profiling the application, and it shows you, hey, this is all the stuff that's happening on your main thread, and the execution time it took, the time it took to execute the scripts and render the DOM elements and all that sort of thing, and even your network requests or whatever things that are in there, based on the timeline of how long it took to get to the, where is it? Get to the the first contentful paint and DOM content loaded. These are all related to those core web vitals and the onload event, which is like, hey, everything's loaded, right? So these are super useful. And this is the journey that most front-end developers take into initial observability. But today we're going to go a little bit further. We're going to go a little bit further, and we're going to understand how to see that within the context of our real users. Now, it should be said, I think something that I glossed over was that in the core web vitals there are there are targets that are generally accepted across the web of things as what they should be. So core web vitals are measured in the 75th percentile. They are for the largest contentful paint. You want to hit a 2.5 second or less to that time. So 2.5 seconds or less is in the green, and anything above that starts to get you start to lose users. And then with the first input delay, I believe it is 100 milliseconds is the target there. And with the cumulative layout shift, it is measured in a percentage. So it go, I think it's like 0.0 something usually is an average score, but you don't want to get above 0.1 is how they measure that. So that information will be useful as we look into how this looks within RUM. So as you can see here, you'd be asking yourself questions like, hey, was the largest contentful paint around 100 milliseconds? You got to start to think in terms of that sort of latency. Great. So now that we've kind of seen, what it looks, what it looks like in the common user journey or the common developer journey to be able to track, like how many milliseconds it took in, Lighthouse to be able to have your LCP event. Let's look at it in Datadog and see what's going on there. So, yeah, so RUM is super cool. Let's check it out. So here's my RUM view. Real user monitoring view, and I have my app configured as I showed you earlier for StoreDog. I'm going to open that up, And out of the box, this is the past day. So I'm going to set my time window to probably the past 5 minutes or 15 minutes or what have you, since we've been doing this. But out of the box, as you can see, great. I don't have any issues yelling at me at the moment that are surfacing, but I can track these core web vitals right here, just in the initial view. So I have my largest contentful paint right here, and I can see that for some of my users, it's getting a bit out of hand. There's a lot of mobile traffic that hits this site, so you can guarantee that these users, may or may not be sticking around. But out of the box, just in this initial view, you can see that, you can see how many sessions have been within, that time duration and what their average duration was, what kind of browsers they're using, what the routes are that are hit the most, the regions that they're in, and you can continue to look through things that are important to this context in the front end. But there's a lot more that you can do and should do to understand what's going on with your core web vitals. So the other surface areas that are important to look at that you want to check out for this are performance. So if you head to, this is a dashboard, so for performance, so you get a little bit more of a view that's oriented towards that. And in this context, I've got my core web vitals right here, and I can see that it's kind of following the same pattern. Now, as you notice, this looks like an oscillation. This looks like like a waveform or something, and that's because I'm simulating mobile traffic right now, and it's repeating the same user journeys or session replays over and over through Puppeteer. So that's why it looks like this waveform, but in a real scenario with that, you would see you might see users all over the place here, and I'll get into this later, but it's really what's amazing here is that you can we'll be able to mitigate this, and you'll also be able to track when users get beyond a certain threshold, so that you can alert yourself to that and dive into any issues that are causing that. So that's really exciting. And this is the dashboard for performance. So I've got my core vitals right here. I can see that my total page views within the last 5 minutes, 72. My P75 loading time, which is the way we're measuring the loading time, is on average about 5 seconds, which isn't great, but we're going to work on that in a minute. And then as you can see, as you skim further down here in the view, you can see what's going on, with the number of requests you have, like your XHR, your fetching requests, and how many, what the duration was based on the route and all that kind of stuff. So this is all like good general information about what your performance is actually, like with your real users. But in order to take that one step further, it's also important to view your sessions. And this allows you to kind of see what's going on at a granular level with each user. And you get kind of a waterfall here to be able to understand what your largest contentful paint is, what your core web vitals are at the moment, and what is causing them. And where it actually sits within that time frame. So this is going to be all super useful information as we continue through this, and will help us investigate and understand how to mitigate these issues. So I've kind of gone through the performance overview and shown you what we're going to look through to be able to solve some problems with our user experience here. So yeah, I mean, when we audited the page with Lighthouse, you saw that it was really, really bad. Also, you can see when we're looking at the dashboard that the performance of this site is super bad. And yeah, and I mean, we can take a look in closer here. Oops. Yeah, we can take a look in closer here and start to see that, within the context of these three tabs, or these three surface areas, like the dashboard view and the session replay, we can start to dive in and see where things are going wrong. So it seems like we have a lot of code that needs to be that's getting sent up. There may be some caching that needs to happen here. We have some long requests here that we'll need to be able to dive into to be able to bring these request times down, hopefully. And that's going to be super important. Let's see. So, yeah, it's important to also, in a view like this, you can see what there's long task view here that kind of shows you, where the main thread is being blocked and at what point. So this is also very handy for being able to understand, like why, at what point the problems are surfacing. But one thing I should mention about logs and why it was important to instantiate logs is because if you instantiate your logs and you upload source maps from your application, you'll be able to pinpoint where the latencies began pretty much to a line of code. So it gets really cool when you start to dive in to that, and we will here momentarily. So in this narrative, right, that I have written here for you, we're tracking the largest contentful paint scores, and we saw that that's happening way out. It was happening way out here somewhere, right after all this stuff rendered. So we know this is an issue, and we know this is an issue. And if you click on that, you can start to see, get a deeper flame graph view to understand what's going on. And we can see that, maybe in our Python Flask request here, the get request for this discount is taking an inordinately long time, 2.5 seconds. And then the same thing for it's the same thing for we can see our LCP is really bad, and then we know it's the same thing for our ads, because that looked like it was taking a long time too. And there you go, we got a Flask request, get request, that's also taking about 2.5 seconds. So that is undesirable. And now let's now that we can see, sort of, maybe I can summarize a little bit. I feel like I went through this fairly quickly. It's probably good just to review this for a moment, going back to real user monitoring and looking at our application overview, going to the last 5 minutes. What we want to do is we want to be able to use these dashboards to see that these scores go down, right? So we can see that on average, there are a lot of users experiencing a largest contentful paint event at 10.8 seconds, which is awful. So, what we want to get with our mobile users is to be able to get this score down. Now there are, we've got sort of a yellow window here and a green window or threshold, and our green threshold is 2.5 seconds. Anything that's 2.5 seconds or below is going to be you're going to be fine, as far as we know statistically, right? With the common scores that everyone is using right now, the P75 scores, and then or metric, and then above that, pretty much between your 2.5 to 3.5 seconds, you've got sort of a like a yellow window here, and that's okay. But you might start to lose some users, and then if you're in the red, it's just you're in for a bad time there, because you want to keep them around, right? And so we're going to be using this and this dashboard to be able to kind of see this more granularly, and hopefully we can get these scores down. So let's see what we can do with a bad report. So this is going to lead you, as you take this course, this is going to lead you to searching for the type and the app ID and what you need to be able to see, various paths within your application, or in this context within StoreDog, to be able to bring your score down and see what's going on. So I'm just going to, but I've demonstrated quite a bit of that already. So I'm going to head over to my app again, and go to my sessions and replays. I'm going to start to see what's going on. So as we talked about before, we can see that, in a session where the score was really bad, which most of them are, 11.67 seconds, there are some things that we want to do. There's some performance optimizations that we can make already. Now, I know that this application is loading all of the JavaScript and CSS and the assets, like, on every request. And like, why the heck is that happening? That is an obvious performance optimization that could happen. You don't want to be loading all this on every request, because you're incurring a large performance hit. But I do know that within the context of this application, that if I head to so app, so within my app, if I'm in the front end and I go to the configuration and the environments, and in the development environment right now, somebody had set up some caching for that, because as they said here, in this development environment, the app's code is reloaded on every request instead of caching it and then sending it over when a request comes in. So we know that this is an obvious performance hit for the front end here. And fortunately, what they've done is and all we need to do here is enable caching. So there we go. So we've enabled the cache. However, we do know that we need to restart the front end service for that change to take effect. So let's do that. Let's go ahead, and since we've made, so in this lab, any change that you make to the app will be saved automatically. And then you can follow the instructions to be able to do what you need to do next. Like in this case, we need to restart the front end. So we're going to do that. And pretty much immediately, since we're not grabbing all the scripts every time and whatever to be executed from the back end, that should save us some time. So okay, so we've got that going. Also, I don't think I really mentioned, and it's important to mention that an easy way, even without mobile traffic, an easy way to test sort of your scores, and another way to see how it's working is to navigate around the site yourself. So you can definitely navigate around and and that will aggregate your data as well up to Datadog. So I'm going to reload this a couple times, and that will show the latency that it took for me, particularly on my browser, to load the initial view or the index. But I also have the mobile traffic going, so we should be able to start to see some changes. And what we're doing right now is trying to bring that largest contentful paint score down. And sometimes it takes a couple minutes to aggregate the data and to see those changes propagate, but they do, and they will. So let's see if they, in this Chrome mobile session, let's see if this has changed yet. Okay, that brought, I mean, even though this is still bad, right? It's still above that 2.5 second mark. That significantly decreased the time it took to load by like half, because it was at like 11, right? So you can see that here, this largest contentful paint was at 5.5 seconds, and that's because we're caching we're caching these scripts now, instead of trying to load them every time we request on the back end, which is great. So now we've got that going, and that significantly improved our performance. And we can head over to our RUM app again and kind of see what that looks like in the dashboard. So I'm going to go back to 5 minutes so that we can see. Now this was at 7:41, so it might still be updating here on the dashboard. But really, what we care about is seeing if this line goes as far up as it did before. Right now it's at 5.26 seconds. Maybe we can take a look at a dashboard as well and see what happens. So I'll head over to the performance dashboard. We'll see how that's going. Okay, you can start to see it arcing here, right? So we know that, yeah, you can start to see it arcing there instead of going vertical, I think is what's happening, which looks good. Let me get one more second and we'll see. Yeah, okay, great. Okay, so we can see that, here was here's the peak, right? And that was at 5.26 seconds. We brought this poor performing score down, and we can see that our largest contentful paint is now averaging around 5.2 seconds, 5.26 seconds, which is awesome. We just made a dramatic increase in our performance there. But there's more that we can do to mitigate this issue, and we want to, let's look at this in the context of the sessions. Okay, so we'll go back to our sessions, and on that page load, because we're looking at initial page load is what we're focused on with the largest contentful paint, and we can still see that even though we've done this, we still have this issue because we don't want our users bouncing, and we want a delightful app, right? So now we're going to focus in on the discounts and the ad services, which seem to be taking up a lot of time. But I'll draw your attention here first. As I noted before, you can see that the first contentful paint is noted here, and then your largest contentful paint is noted here. And what we want to do is try to bring these as close together as possible. That's what we're focused on right now. The largest contentful paint happens after all these XHR requests are made, and the data is, the payload's returned, the data is returned, and things are rendered in the view. So this is happening after our LCP is happening after the discounts and the ads are rendered. So let's see what we can do to fix those. So if I click in here on this, I noted before that most of the Python Flask request, it's a request library. So most of the requests that are being made here seem to be averaging around 5.8 seconds. What the heck is going on with that, right? So if I scroll down a little bit here, because I had my source maps uploaded and my logs enabled, if I head over to logs, which is propagating in as well, I can see that I get this information here about, okay, well, within this particular request, it was, around this timestamp, it's happening from the discount service, and the latency of this request seems to be starting around this line of code, which is discounts.py. That's where this gets called. So let's use this to see if we can figure out what's going on in discounts.py. I head over there, go back to my IDE to where the app is, and close this. I'll head over to the ads or the discounts service, right? And there it is. There's discounts.py. And just so you know, you'll be able to follow along with what I'm doing as it's noted here. So don't feel like this is not repeatable, because everything I'm doing, you'll be able to redo yourself here, and it's noted here pretty much step by step. So that should be super helpful for you to do on your own. So in discounts.py, it said, what did it say? It said line 30, I believe. I think it said line 30, around there. Okay, so I'm looking for anything that's odd. It said it started around here, and I can see on 37, it says time experiment. That's weird. Do not release to production. Great. They put a sleep in this service, which is not actually that uncommon, because people are trying to keep away from race conditions. You might want to boot up your service after another one starts, like the environment and the front end and whatnot. So it looks like somebody was trying to resolve that here in this discounts script. So that's no good for our LCP. Let's get rid of that. Okay, so we got rid of that sleep. That should really help us, and we can return over to Datadog and start to see now that automatically saves, and we should be able to start to see our score improve still. And again, it can take up to a couple minutes or so for the data to propagate into Datadog. But obviously this is real time or near time or whatever. So let's see if those changes have come through yet. I don't believe they have. Well, it's shorter than before. Yeah, this is still the same. So they haven't come through yet, but they will. And again, I think it's worth noting, and I'll show you briefly at the end here, that what you can do to do this on your to automate this so that you don't have to do it by yourself. I think I am getting a bit short on time here, though, so I'm going to try to okay, look, you can see that the discount service is now way faster. It's at 2.3 sorry, it was like 236 milliseconds or something. So we know that worked, right? That helped us. And again, if we go over here, we can start to see that LCP continue to drop. Okay, and it's still not perfect, but we're getting there, right? Okay, and so for the sake of time, because I know I'm getting to time here, I think that I'll run to the ads service. We also noted that ads has the same problem. Not Bootstrap. I want ads.py. Ads had the same problem, and if you navigate to that log, you'll see that that it's the exact same issue. Somebody added a sleep here. So if we get rid of that, you'll see the score improve more as well. And after I do this, it's not perfect still, but there are a number of optimizations that you and your team can decide to make, performance optimizations to your app. And one of them might be, hey, we want to do server-side rendering. Maybe we don't want to have a million XHR requests from the front end and have to wait on those to get our score down. Maybe you want to just send. Maybe you just want to do server-side rendering in this case, and so instead of trying to execute the services on the front end, right? And so, or waiting for them to complete, right? So like, what I'm going to show you is, I've made the updates to the ad service. I've made the updates to the discount service. That's going to bring my LCP down to, a pretty good place, but it's still not green. So what I'm going to do is switch over to a container that is doing server-side rendering instead of doing all these XHR requests on the via the front end. And you can see that also increase dramatically to where it actually should be. And then I will be wrapping up here in about 2 minutes. I know this was a 50-minute session, so I want to respect your time, and I'll be wrapping up here in 2 minutes. But I'm rebooting these after killing them. So let's see. I'm putting those down, then I'm bringing them back up with the new server-side rendering in place. And okay. Here we go. And that's loading. Okay. All right. So let's see if StoreDog loads here. So it's still waiting because they're booting up in the back end. But it should be loading here in just momentarily. And then I want to show you both the visual increase in performance and then also in Datadog in RUM. Okay, here we go. So on this initial load, it might take a moment just to boot up via instruct. This is not an app problem. This is via the lab. It's just taking a moment to load. But in the meantime, let's try that again. Yeah, okay. Let's just try that one more time very quickly. StoreDog, okay. Okay. Yeah, so that loaded, when it was time to load the app, it loaded fairly quickly, much quicker than it used to be. And now you can see that, let's refresh this and see how things are going in the past 5 minutes. You'll start to see this drop dramatically. And in the app, if you go to the sessions and replays, and you look at what's happening right now, since we're doing a bunch of server side, it hasn't propagated yet. But you'll see this. I know we got to go. You'll see this drop to significantly, below 2.5 seconds. And I think the most important thing for teams of front end engineers to remember about this is that this is all great and wonderful if you are doing this, manually like this, which, is great to be able to dive in. As you can see, it started to drop, and as it propagates in more from the changes we just made, you'll see this stay in the green. But the important thing here is that you can set alerts for yourself, create a monitor, right? So you can create a monitor based on this LCP score, and that if this drops below a certain threshold or above a certain threshold, then you can alert your team. You don't have to watch this, right? So if I go like 2.5 seconds, right, that might be my alert threshold. Or actually, like, let's say my alert threshold is like 3.5 and my alert threshold is 2.5 seconds, right? So if it's over the green, give me a warning. If it goes into the red, then alert me. I don't want my users experiencing that. And within this, you can notify any of the members on your team, send them an email with what's going on, and go from there. And a lot of these issues can be resolved even before they go out to production, which is really, really exciting. And this is what makes tracking what's going on with your real users awesome. And so anyways, I hope that you enjoyed this session and got a lot out of it. I know that we went about 6 minutes over, but I hope that you will join us and follow along with in your own time and get into the practice of observability in the front end, because it's so important to be able to create a good environment for your users to use and enjoy. So thank you for your time, and thanks for everything and joining me today. I really appreciate it. Had a great time doing this with you. And please feel free to reach out to me individually if you want to ask questions as well. I am open source, so open source with a B, pretty much everywhere on the web. So Twitter, wherever, if you want to reach out to me, please do. Really enjoyed doing this with you today, and we'll see you next time.